In this tutorial, we will take a look at the cluster evaluation procedure, which can be used to assess the quality of observations grouping. This assessment is based on the analysis of the silhouette coefficient. The silhouette coefficient combines the concepts of group cohesion, favoring cohesive groups, and their separation, favoring groups that are well separated from others. It can be used to evaluate individual observations, groups, and models. The silhouette coefficient ranges from 1 to 1, where higher values indicate better clustering quality. It is generally accepted that an average silhouette value greater than 0.5 indicates good data separation. The distances of observations are calculated using Euclidean distances relative to the group centroids. In the dataset, we have several variables on which one of the clustering techniques, the two-step cluster analysis, has been applied. As a result, we obtained a variable indicating the group membership of observations specified in this analysis. Using the cluster evaluation procedure, we will aim to learn more about the result of this clustering. Let's get to action. From the Predictive Solutions menu, select Analyze, then Cluster Evaluation. To use the procedure, we need a variable containing information about the group membership of observations. Such a variable can be created, for example, using clustering algorithms available in IBM SPSS statistics. In our case, it is the variable cluster number in two-step clustering, which should be entered into the cluster membership field. In the Based On field, there should be variables that were used to create the groups, which in our case are education, position, and current salary. Under the Save button, we have the option to save several values as variables: silhouette values, distances from cluster centers, and next best cluster ID. For our example, we leave the Save options unchecked. Under the Output button, the option to generate tables and charts with results is checked by default. If we are only interested in saving the results of the procedure to the dataset, we can uncheck this option. We will leave it enabled, click OK, and then OK. After running the procedure, we will obtain several result objects. The first is a chart that shows the average silhouette value for all observations along with markings to help determine whether the group division should be considered poor, silhouette less than 0.2, average, silhouette between 0.2 and 0.5, or good, silhouette above 0.5. In our example, the overall silhouette measure can be considered good. The next object is a table containing statistics for the silhouette measure, such as mean, minimum, maximum, range, standard deviation, and count. The statistics are presented broken down by group and in total. It turns out that while the overall silhouette value is good, the situation is not as positive in all groups. Problems occur in the second cluster, where the average silhouette measure is approximately 0.7. We will see this even better by analyzing the next result object, the distribution of silhouette values broken down by cluster. A layer chart has been created for each group. Observations are sorted in descending order according to the silhouette value. Reference lines on the charts make it easier to determine what proportion of observations have acceptable silhouette measure values. In the case of the second cluster, all observations have unacceptable silhouette values, and nearly half of the observations are closer to another cluster than their own, indicated by silhouette values below 0. The next result objects will help us better understand why this is happening. Let's look at the charts showing the distances between the center of a given group and the centers of the other groups. The center of the group for which the chart is generated is always shown in the center of the chart. These charts can be used to assess whether the groups are well separated from each other. As you can see, the only cluster that is well separated from the others is the third cluster. The first and second clusters are the worst separated from each other. Finally, it is worth looking at the graphs showing the dispersion of observations assigned to a given group relative to its center. They also provide information about the mean and standard deviation of the distances of observations from the group center. The most clustered observations are in the first and fourth groups. The largest dispersion of observations occurs in the second cluster. In summary, as you can see, despite an acceptable silhouette measure value of 0.53, A detailed look at the specified groups reveals that they are not ideal, and the clustering itself would require further attention from the analyst. The cluster evaluation procedure allowed us to examine the quality of the clustering from many angles.